We're now going to begin to talk about function notation, which is an extremely important idea, which is going to come up again and again throughout the course. So it's really important that we get a firm foundation of it here to understand what it is. And as the name would suggest, it's just the notation we use when writing down a function. So here is our function notation. So we start off with a letter, and it doesn't necessarily have to be F, but in this example, it's F. Then we have two dots, so a colon, and then we have this X right here. Now what this X stands for is the domain. So we write down what the domain is. Then we have an arrow, and then after the arrow, we have this Y. Now this Y is standing for the codomain. Now the codomain is, we'll get to that later, what exactly it is, but I don't want you to stress too much about it. And then what we have afterwards is we have that same letter that we started with. So if it was F, then we write F again. Then with brackets X is equal to whatever the function rule is. So let's now kind of break down each of these components. And then as always, once we go through an example, it will make a bit more sense. So functions are denoted with lowercase letters. Usually you'll see F, G, or H. So in this example, we've used F. Now, as we can also see, we have these two components to our function notation. We have our domain, and we've all seen the domain before. We know what it is. It's just all of the X values that are relevant to our function, so the X values. But what's a codomain? Well, the good thing about this is that in Year 11 methods, you only ever have all real numbers as being the codomain. So you actually don't have to worry about it. As long as you know that this right here is always going to be all real numbers, you'll be fine. If you want a bit of a definition, but again, you don't really need this, the codomain is the set that contains the range. So as you can see here, the codomain is this big circle, and then within it is the range. So you don't really need to know this. All you need to know is that the codomain is always all real numbers, and you'll be fine. All right, let's go through some examples here and cement this idea in our heads a bit more. So let's say you had the function y is equal to x squared with a domain of R. Well, the way in which you would use function notation to write this down is you would say, well, f colon, this right here is my domain. So this all real numbers here, I'll highlight it in blue, that's my domain. And then I've got an arrow, and then the next R, that's my codomain. Then we've got a comma, then f of x is equal to the function rule. So in this case, x squared. Let's look at another one now. So if we had the function y is equal to 2x minus 1, and we have a restricted domain. So we have a restricted domain of, and let me just get these colors correct. We have a restricted domain of x as an element of 0 to 4. So now when we come to write down what this rule is, we're going to begin by saying, well, let's use g this time. So g colon, and then the first thing that we write down is what the domain is. So we write down the domain, then we put an arrow, and then this right here, this R is my codomain. And I said the codomain is always just going to be all real numbers. So don't even stress about it. Just remember, it's always going to be all real numbers. Then you've got the same letter that we started with. So if it's G here, then it's G there. If it's F there, it's F there. G of X is equal to, and then the function rule. And now let's look at our next one here. So we've got for the function y is equal to 1 over x. This time we have a domain of all real numbers excluding 0, and that makes sense. We can't have 0 here, otherwise it would be undefined. And you can see what we've got here. So this time we're using the letter H, which is fine. We could use any letter that we like. And then we have a colon, then we have our domain, then we have an arrow, then we have our codomain, which again, do you see how my codomain is always just all real numbers? So don't even stress about it. Then we have h of x written like this, and then our function rule. So that is how this operates. So let's now dive into this example here and see if we can do it. So it says rewrite each of the following using this notation. So let's see how we go with it. Hopefully we are successful. So you might like to pause the video after I do the first one and then see if you can do it yourself, or you might like to pause it now and see how you go. The beautiful thing about videos is that you can pause and give it a go. All right, so we're going to begin by going f ... Then I'm going to write down my domain. Now I'm going to take the maximal or implied domain. So in this case, it would just be all real numbers. Then I put an arrow. Then I put my codomain, which remember is just always all real numbers, comma, f of x is equal to my rule, which is just negative 3x plus 2. And I'm done. All right, you might like to pause the video and see if you can do the next one yourself. Okay, this time, let's not use f, let's just use g. So I'm going to go g dot dot. As you can see, this right here is my domain. So my domain is x is greater than or equal to 0. We don't use inequalities when we're writing it in function notation. So the way that I'm going to write this is I'm going to say it's from 0 to infinity. So I'm including that 0, so I've got a square bracket on it, and that's because I've got it greater than or equal to. Then I put my arrow. I've got my codomain, which remember is just always all real numbers. Then I'm going to go g of x, because remember I used g at the start, and then I'm going to write down what the rule is. So negative 2x plus 5. We come to our next one, and again, you might like to pause it and see if you can do it yourself. This time, let's just use h. My domain this time is this thing right here. So it's going to be brackets negative 1 to 2. So again, you can't use the inequalities. You have to write it in this interval notation here. So negative 1 to 2. My codomain is always all real numbers. I'm using h, so I'm going to go h of x is equal to, and then I write down what my rule is, 5x squared plus 6. And last but not least, again, you might like to pause the video and see if you can do it yourself. We're going to go f. And now, do you see how it's saying x cannot equal 2? And that makes sense because if I put a 2 in here, I would get a denominator of 0 and the whole thing would be undefined. So I'm going to write this as all real numbers excluding 2. So that's the way I'm going to write it. All real numbers excluding 2. So that's my domain. My codomain, remember, it's just always all real numbers. So hopefully that's burnt into your brain. Then I'm going to go f of x is equal to 1 over x minus 2 squared. Perfect. So again, just to stress this point, you have to make sure that you've got your correct domain starting it off. So the correct domain. So that is the first thing that appears, the correct domain. And then the second thing that you have is the codomain. But remember, it's always, for you guys, always just going to be all real numbers. So don't even stress. Just remember the second thing that you write is all real numbers, which is the codomain. All right, hopefully you found this a helpful introduction to function notation.